Hello everyone, welcome to my channel, and today I want to solve with you such an interesting Olympiad problem. So, prove that the number which in the decimal system is expressed by means of 91 unities is a composite number. First, try to solve this problem yourself, and then you can watch my solution. So, since 91 equals 7 times 30, the digits of the given number can be divided into 30 groups containing 7 unities each. So we have 1,111,111 and so on 30 times. This shows that the number in question is divisible by 1,111,111. The quotient is 10,000,001 and so on 0,000,001. More precisely, let 1,111,111 equal n. The given number can be represented as the sum of the 30 components. So, let it be L equal n times 10 to the power of 84 plus n times 10 to the power of 77 plus so on plus n times 10 to the power 7 and plus n, and this L corresponding to the 30 groups of digits. By factorizing, we obtain that L equal n times 10 to the power of 84 plus 10 to the power of 77 plus and so on plus 10 to the power of 7 and plus 1, which shows that the given number is a product of two natural numbers different from 1. In other words, it's not a prime number. Another factorization of number L we will obtain by dividing its digits into 7 groups containing 31s each. It will then be observed that number L is divisible by the number 1,111,111,111,111. Let this number be m. We can also reason in the following way. L equal 1 plus 10 in the square plus so on plus 10 to the power of 90. Number L is thus the sum of 91 terms of a geometrical progression having 1 as its first term and 10 as a common ratio. According to the well-known formula for the sum of the terms of a geometrical progression, we have L equal 10 to the power of 91 minus 1 divided by 10 minus 1. Hence, L equal 10 to the power of 7 to the power of 30 minus 1 divided by 10 minus 1. That equal 10 to the power of 7 to the power of 30 minus 1 divided by 10 to the power of 7 minus 1 times 10 to the power of 7 minus 1 divided by 10 minus 1. Since for arbitrary A isn't equal B and A natural n, A to the power of n minus B to the power of n divided by A minus B is equal A to the power of n minus 1 plus A to the power n minus 2 times B plus so on plus A times B to the power n minus 2 plus b to the power n minus 1. So, and since we have this equation and condition, we find by substitution in the above formula first a equal 10 to the power 7, b equal 1, n equal 30, and then a equal 10, b equal 1, and n equal 7. So we find that each factor on the right-hand side of formula is equal to a natural number different from 1. The factors are the same as L equal n times 10 to the power of 84 plus 10 to the power of 77 plus so on, plus 10 to the power of 7 and plus 1. Analogously, L equal 10 to the power of 30 to the power of 7 minus 1 divided by 10 minus 1 equal 10 to the power of 30 to the power of 7 minus 1 divided by 10 to the power of 30 minus 1 times 10 to the power of 30 minus 1 divided by 10 minus 1. I want to make a little remark. The theorem provided above is a particular case of the following theorem. If all the digits of number L written in a certain positional, not necessarily decimal, notation are unities, and the number of these unities is composite, then number L is composite. This theorem can easily be provided on the slide of the preceding proof, but I'll leave this proof for you, so that you can practice a little. And by the way, the inverse theorem isn't true. So, if the numbers of digits of L written by means of unities alone is a prime number, then L can be either a prime number or a composite number. For example, in the decimal system, 11 is a prime number, while 111 is divisible by 3, and 11,111 divisible by 41. In the binary system, 11, 111, and so on are prime numbers, while 1,111,101,111,111 is a composite number. And it isn't known yet whether is every sequence of numbers whose digits in a certain positional system are all ones there are infinitely many prime numbers. Neither do we know whether there are infinitely many composite numbers in every sequence of that kind. Well, that's it. Thank you very much for watching this video. I hope you like it. If yes, I will be very glad if you subscribe to the channel and suggest a topic for the next task in the comments.